Gelap lagi lah. Okay, untuk chapter 4.3, okay, Bluetooth. Much of the WPN focus today is around Bluetooth. Okay, started with Ericsson's Bluetooth project in 1994, named after Danish King Harald Blatton. Okay, in AD 1940 until 1981, sebelum Masihi lah kan, who was fond of blueberries kan. Radio frequency communication masa tu pakai Intel, IBM, Nokia kan. Kamu sebut tadi Nokia 3310. Toshiba and Ericsson formed Bluetooth SIG in May 1998. Okay, SIG ni ada special interest group yang nak buat apa nama kajian lah, research on Bluetooth kan. So dia nak buat eksperimen, kita nak buat satu benda nama dia Bluetooth. Okay, so dia buat daripada May 1998 dan dapat dia punya output dia naik dekat 1999, akhir tahun lah, dekat akhir tahun lah kan. Nak masuk tahun millennium dah, 2000 kan. Version 1.0A. 1.0 pun ada A version kan. Okay. After 2 years, tahun 2002 kan. 3 years lah kalau 1999. Tapi 1999 pun dah dekat Disember dah kan. Terus, okay, nama dia IEEE 802.50.1. Okay. So key features dia adalah low power, lower power about 10 microampere in standby, 15 microampere while transmitting. So device dia pun cheap, about $5, and chip dia pun kecil dalam 9mm square kan. Single chip millimeter square ni. Dua tu patutnya kecil je. Mana lah, saya tukar pula. Mana kecil kan? Superscript. Itu. Itu. Save. Okay, ni frekuensi dia. Okay. Kalau kita tengok on band frequency range daripada 2.4 GHz kan. Dari 2.4 GHz kita start pakai Bluetooth dekat 79 Bluetooth frekuensi. Okay, kat sini. Okay, semua ada 79 MHz band. Kecil je kan. Okay, so tapi dekat certain country, Spain ada pakai 23 MHz je. Okay, dia punya 2.4 tu dia ambil 2.4 GHz. Kalau tukar megahertz jadi 204,000 something lah. Dia ambil 2402 until 20780 lah, ataupun 2.48 GHz kan. So data rate dia masa tu adalah 1 megabit per second. Version 1 per second. Version tu juga dia punya 3 megabit per second. Dia upgrade sikit daripada version 1 kan. Okay, bandwidth dia, channel bandwidth pakai 1 MHz. Range up to 10 meter can be extended further. Untuk radio frequency hopping ada 1600 times per second. Okay, lebih kurang 625 microsecond per hop kan. Security masa tu kita pakai challenge dengan response authentication. Okay, ada encryption key juga dalam 128 bit encryption key. Okay, output power. Okay, output power dia ada 3 kelas kat itu kan. dB apa? Decibel lah. dBm. Okay, 20 dBm max W watt kan? WATT. Okay, class 2 4 dBm about 2.5 milliwatt kan? Sikit-sikit kan? Kelas 3 tak sampai pun 0 dBm kan? Dia dalam 1 milliwatt, lagi kecil lah power kita pakai untuk 10 meter, connection 10 meter. Okay, untuk connection dia Bluetooth can connect up to 8 devices simultaneously. So Bluetooth use a transmission technique called spectrum frequency hopping ataupun FHSS. So macam mana dia buat adalah guna randomly chosen frequency within a designated range, changing from one to another on regular basis. So the transmitters change frequency. So meaning that more devices can make full use of a limited slice of a radio spectrum. Since every Bluetooth transmitter use spread spectrum transmitting automatically, it is unlikely that two transmitters will be on the same frequency at the same time. Okay, macam mana how Bluetooth work? Okay, how Bluetooth operate? When Bluetooth capable devices come within range of one another, an electronic conversation takes place to determine whether they have data to share or whether one needs to control the other. So the user doesn't have to press a button or give a command. The electric conversation happen automatically sebenarnya. So once the conversation has the occur, the devices, whether they part of a computer system or okay, they create a PAN yang kita kata WPAN kan, ataupun Personal Area Network. So ataupun Piconet, nama dia scientific dia kita panggil Piconet. Pico macam Dragon Ball tu, Piconet. That may fill a room or may encompass no more distance than that between the cell phone on a back clip and the headphone on your head. Once a Piconet is established, the members randomly hop frequency in unison so they stay in touch with one another and avoid other Piconets that may be operating in the same room. So maksudnya dia macam lock lah, tak boleh bagi orang lain pakai kan. So ada dua, selain daripada Piconet ada Scatternet. So ini kita panggil dia sebagai topologi. Okay, Bluetooth topologi yang kita tengok tadi Piconet, satu lagi nama dia Scatternet. A Piconet consists of to 8 Bluetooth enabled devices yang connect together tadi kan. So when a Piconet is established, one device set the frequency hopping pattern and the other devices synchronize their signal to the same pattern. Satu dah establish, dua device yang lain akan follow. The device that sets the frequency hopping pattern is called the primary device and the other devices are called secondary devices. Okay, device yang set dengan frequency hopping pattern ni tadi nama dia adalah primary device. Yang lain-lain nama dia secondary devices. So each Piconet has a different frequency hopping pattern to differentiate its signals from the signal of other Piconets. Okay, so contoh kat sini kita ada dua Piconet, Piconet A. Headphone pun ada boleh connect dengan mobile phone. So yang mana yang secondary, yang mana yang primary. So primary dia adalah headphone kan. Dua-dua lagi dipanggil secondary device, sama ada handphone ataupun smartphone ataupun laptop yang boleh connect dengan headset tadi kan. Headset ke headphone? Apa beza headphone, headphone, headset, earphone? Ada beza ke? Nama lain-lain ni? Earphone, ada lagi earbud kan? Oh, lain lah, asal lain. Earphone mungkin dia dekat macam earbud, masuk telinga je kan? Kalau headphone tu maksudnya yang ada bulat tu, betul ke tu? Tak tahulah kan, mungkin. Saya pun tak tahu. Tanya kamu lah. Sebab nama earphone kan. Tapi semua letak dekat ear. Tak ada yang letak dekat hidung kan. Hidung jadi nose. Okay, so tengok yang ni. Contoh primary device dekat Piconet B ni. Dia ada laptop yang connect kepada semua. Semua yang lain connect kat dia, kita panggil dia secondary. Telefon boleh connect dekat dia, printer connect kat dia, PDA connect kat dia. Okay, dalam Piconet, Bluetooth enable electronic devices so connect and communicate wireless through short range ad hoc network known as Piconet. Up to 8 devices in one Piconet. So yang tadi panggil primary dengan master, primary dengan secondary, satu primary dan 7 secondary, 1 master and 7 slave. So dalam devices, range dia adalah about 10 meter. Okay, Piconet boleh range sampai 10 meter jauh dia kan. Piconet are established dynamically and automatically proximity. Okay, contoh ni dia buat dalam bentuk handphone, laptop kita tengah ni biru. Yang lain-lain tu ada Bluetooth, printer, mouse, keyboard, apa lagi? Bluetooth apa lagi? Headset, headphone, kamera, apa lagi ya? Jam, wristband. Satu lagi apa nak buat? Scanner dah pakai tak? Bluetooth scanner. Macam slow kan? Ataupun dia connect dengan handphone kan? Handphone. Ada banyak handphone. So the Piconet operation pula. The Piconet master is a device in a Piconet whose clock and device address are used to define the Piconet physical channel characteristic. All other devices in the Piconet are called Piconet master and one slave. So the master switched rapidly from slave to slave in a round robin fashion. So dia nak connectkan 88 tu, dia akan bagi turn, ikut turn kan, ikut turn. Siapa yang nak cakap dulu kan. So, tapi benda tu laju, benda tu turn tu laju. So maksudnya jangan risau. Kata sahab nak kena tunggu turn tu lambat kan, dia laju dalam microsecond kan. Any device may switch the master slave role at any time. Microsecond ni berapa? Satu bagi berapa saat? Satu bagi billion saat kan. Kalau millisecond, satu bagi ribu, microsecond satu bagi juta, 1 juta. Nanosecond baru satu bagi billion. Sorry. Okay, let's say you have a typical modern living room with typical modern stuff inside. Ni contoh kita pakai Bluetooth. There's an satellite TV receiver and a television. There's also a cordless telephone and a personal computer. Each of these systems use Bluetooth and each form its own Piconet to talk between the main unit and peripheral. So the cordless telephone has one Bluetooth transmitter in the base and another in the headset. So the manufacturer has programmed each unit with an address that falls into a range of addresses it has established for a particular type of device. When the base is first turned on, it sends radio signals asking for a response from any units with an address in a particular range. So since the headset has an address in the range, it responds and a tiny network is formed. Clear? Macam satu-satu tak faham, baca balik, ulang balik kan. Now, even if one of these devices should receive a signal from not from within the network, the computer as entertainment system go through similar routines, establish network among address in range established by manufacturers. Okay, so once the network are established, the system begin talking among each other, baru they start connect, hantar data kan. Each connect hopes randomly through the available frequency, so all of the connect are completely separated from one another. Now the living room has three separated network established. Ikut contoh tadi kan. Each of one made up of devices that know the address of transmitter. It should listen to and the address of receiver it should talk to. So since each network is changing the frequency of its operation thousands of times a second, it's unlikely that any two network will be on the same frequency at the same time. So if it turns out for a tiny fraction of a second, so maksudnya ada sikit je kan, tiny second, and software designed to correct for such error without the confusing information and get on with the network business. Kita pergi ke topologi yang kedua. Okay, daripada Piconet kita pergi dekat Scatternet. A Scatternet is formed when two or more Piconet are linked by a common Bluetooth enabled device. So Piconet dengan Piconet ni boleh link pula kan, together kan. So bila dia link, dia jadi lagi besar, nama dia adalah Scatternet. Okay, when a device is present in multiple Piconet, it synchronized to the master ataupun primary device of each Piconet with which it is currently communicating and set the hopping pattern of the Piconet. Okay, so with Piconet, where multiple Bluetooth devices are able to connect with each other in an ad hoc manner, so two can multiple Piconets join together to form a larger network known as a Scatternet. So Bluetooth devices must have point-to-multipoint capability in order to engage in Scatternet communication, and several Piconets can be connected to each other through one Scatternet. So furthermore, a single Bluetooth device may participate as a slave in several Piconets but can only be a master in one Piconet. Okay, ni contoh Piconet combine dengan Piconet. So ini pun ada juga, C dengan H ni adalah Piconet, D dengan E Piconet, tapi D dengan A adalah Piconet. So dia boleh connect A dengan E using Piconet P1, P2 and P3, P1, P2 and P3. So each Piconet is controlled by its spread master ACE and contains one or more slaves. Sama ada slave dengan slave tu yang akan digunakan oleh dua-dua Piconet, ataupun C ni yang digunakan secondary dalam Piconet 1, dia jadi master kepada dalam Piconet 2. Dia boleh jadi macam tu. So combination ni kita panggil Scatternet. Okay, note how device C which connect P1 and P2 is a slave in one Piconet and a master in Piconet 2. P2. Okay. So kalau kita tengok use case untuk Scatternet, an example use case demonstrating the need for a clean high quality implementation of Scatternet is shown in figure below. Ada gambar ni. Kan. Okay, tapi dia punya Piconet dia connect dengan handphone. Tapi handphone ni dia pula menjadi master kepada headset. So kita ada Ethernet kat sini. Ethernet dengan Ethernet. Gambar penting tak? Kan? Okay. So ini primary, ini secondary ataupun ini master, ini slave. Kan? As secondary boleh, slave boleh. Kan? Okay, so ni dalam satu Ethernet. So untuk Ethernet yang kedua, dia ada pakai yang ni, yang P ni. Maksudnya P ni primary ni tadi dia jadi secondary pula untuk Ethernet 2. Ni Ethernet 2, ni Ethernet 1. Kan? Dia boleh connect lah, boleh ada link lah Ethernet 1 dengan Ethernet 2. So here we see a user synchronizing calendars between a phone and a notebook PC while at the same time carrying a phone conversation using a Bluetooth headset. In this scenario, the mobile phone function as both a master, okay, kalau tengok dekat headset, and slave kalau tengok dekat komputer. So in order for this to network regardless of speed, data speed and effective Ethernet implementation is required. Oh, orang Iran. Iran. Ada yang Syiah tak dalam ni? Tak ada kan? Iranian use Ethernet to share videos. Ada tak ada? Mana tahu kan? Yang daripada Wakanda ada? Tak ada. Tak ada. Semua
Firdaus.
tribe apa tu? Dia ada banyak tribe tu.
Firdaus dia dari Wakanda tu tak? Firdaus.
Yeah. Wakanda forever kan? International report on German journal about Iranians using the Bluetooth in mobile phones to from Ethernet, Ethernet for P2P sharing. Okay, dia pakai P2P sharing is then video because the state run ISP limit bandwidth and use smart filter to censor internet access. Sebab tu dia pakai kan? Kat Iran. Okay, Bluetooth ada version pula, Bluetooth 2.1. Okay, Bluetooth 2.1 launch in July 2007. So dia punya features dia enable device connected together in a Bluetooth connect based on code identification without a yes no question query or other verification method. So this is the prime innovation. Okay, nama dia so yang ini dia akan enablekan encryption of data exchange between paired device, making the whole data transaction more secure. The connection between two Bluetooth devices much simpler than before with no need to enter a pin. Kan kalau dulu-dulu kalau pasang dalam kereta kan dia minta pin Bluetooth kan, tu Bluetooth 1. Kan dah tak perlu kan. Kalau perlu pun masuk je lah 0000 kan. Kan dia punya default dah. Okay, so yang ini features baru tak perlu dah pin. Okay. Okay, apa lagi dia punya spek dia? Ada 8DPSK. Dia pakai 8DPSK pi bahagi 4. Pi per 4 divide by 4 DQPSK. PSK ni apa? Phase shift keying and Gaussian frequency shift keying. GFSK. So maximum theoretical response EIR technology which create stronger authentication procedure for connecting Bluetooth devices, reduce the power consumption level of the devices, increasing energy efficiency in the process. Cerita Wakanda tu masuk ni tak? Masuk Malaysia tak?
Dah masuk.
Masuk walaupun dia ada LGBT kat situ kan. Okay, Bluetooth 3, version 3 pula. Okay, dia ada HS features. Launched in July 2009, aimed at increasing the throughput of data exchange over a Bluetooth connection. With the combination of a 2.11 link can provide a maximum data transfer rate of 24 megabit per second. So initial connection is made using Bluetooth frequency, okay, a physical layer at 2.11 link established between devices handle the rest of the heavy data transport, enabling a higher overall transmission speed, a Bluetooth reduction in the power consumption of Bluetooth 3.0. Kan. Tapi kalau dia pakai vibranium, saya rasa tak ada masalah kan. Tak ada masalah nak buat low power ke apa, sebab vibranium tu dia power dia kuat lah kan. Patutnya itulah tu Bluetooth 15, Bluetooth 100 kot nanti. Okay, Bluetooth 4.0 dekat market banyak sekarang ni. In order to meet the increasing demand for wireless connectivity between small devices, sebab dia adalah Bluetooth Low Energy, BLE. Bluetooth 4.0 was introduced to the market with a new category of Bluetooth Low Energy, BLE. So geared towards application requiring low power consumption, BLE returns to a lower data throughput of 1 megabit per second using DGF-SK modulation scheme. Although BLE's met data throughput of 1 megabit per second may not be suitable for product that require a continuous stream of data like wireless headphone, data periodically. An example are fitness wearables that release small amount of temperature data to your smartphone only when requested. Okay. With the focus on keeping energy demands low, Bluetooth Low Energy makes many coin cell battery operated IoT application feasible. So kalau kamu tengok dekat pasaran tu ada Bluetooth 4 tu, kata tak mau belilah, nak tunggu Bluetooth 5 kan, tak payah. Beli je. Bluetooth 4 ni memang okey lah kan. 5 ni dia hybrid yang tadi je lah. Kan? Okay. Yang latest Bluetooth 5 bila ni? Tahun dia tak bagi kali ni. Kan? The most recent version of the Bluetooth protocol, Bluetooth 5, is an improvement upon the previous BLE standard. Kalau kamu beli yang keyboard dengan mouse pakai Bluetooth tu, selalu dia pakai Bluetooth 5 lah. Kita boleh pakai dongle, boleh pakai wifi, apa nama wifi balik. Bukan pakai wifi biasa, pakai dongle. Dongle tu sebenarnya wireless. Kan wireless. Dia pakai USB lah. Kalau Bluetooth ni tak payah pakai USB lah kan. Connect terus dekat laptop ataupun handphone. So yang ini dia pakai BLE. It's still geared towards low power application but improve upon BLE's data rate and range. Dia lebih kepada data rate and range. Unlike version 4.0, Bluetooth 5 offer you different data rates to accommodate variety of transmission range 2 megabit per second, 1 megabit per second, 500 kilobit per second and 125 kilobit per second. Ikut keperluan lah. Kalau kita nak pakai audio besar lah kan. Kalau kita nak hantar signal sensor, boleh kecil. Because an increase in transmission range require a reduction in data rate, the lower data rate of 125 kilobit per second was added to support application that benefit more. Tapi dia punya data rate lebih kecil. So for example, tiny sensor are not required to send large amount of data. So reducing the data rate allow this sensor to transfer information as far as 240 meters. In contrast, the option to transmit data at 2 megabit per second is geared towards application where the range is expected to be short but can greatly benefit from the increase in data speed. So the flexibility in data speed offered by Bluetooth 5 allow low power product to send even more sophisticated data to the end user. Okay, so kita tengok spek dia. Radio and baseband parameter. Topologi dia kita boleh up to 7 simultaneous link. 8 lah. Okay, modulation dia pakai GSK tadi. Radio frequency dia 220 kHz. Pakai bawah negatif 3 decibel. negative 20 decibel. So carrier dengan band, so band dalam 2.4 GHz ISM frequency band juga. Carrier dia dalam 79 kita katakan 23 as reduced option. Carrier spacing 1 MHz. Start pakai free hopping. Spread spectrum kan FHSS TDD. So frequency hop rate dia dalam 1600 hop per second. Okay, untuk transport layer kita ada Bluetooth transport layer is roughly equivalent to the traditional OSI physical and MAC layer. All Bluetooth devices are required to implement this layer in hardware. The transport layer is composed from the radio, baseband and link manager layer. So untuk radio layer, the radio layer dictates the frequency, power and modulation used by Bluetooth antenna. Bluetooth occupies 79 channel of 1 MHz each channel in the 2.4
Sir, suara tak ada, sir.
Hilang terus.
Sir. Sir, suara hilang.
saya hilang pula dah kan. Ni saya pakai line Unify ada problem. So nampak? Sekarang dah okey dah Lik?
Nampak sir.
Dekat nak habis dah ni, sikit lagi. 2-3 slide lagi. Pula. Masa pun lagi 5 minit kan. Okay, kita tambah sikit lagi. Gangguan tadi. Share sekali lagi. Okay, so untuk transport layer tadi. Bluetooth transport layer is roughly equivalent to traditional OSI physical and MAC layers. All Bluetooth devices are required to implement this layer in hardware. The transport layer is composed from the radio, baseband and link manager layers. So modulation used by Bluetooth antenna, Bluetooth occupies 79 channels of 1 MHz each in the 2.4 GHz spectrum from 2.402 GHz to 2.480 GHz. 80 GHz. So Bluetooth specifiers are divided into one of 3 classes which specify the antenna power output power. Class 1 devices broadcast using 1 megawatt to 100 megawatt of power. Class 2 device broadcast using 0.25 megawatt to 2.5 megawatt milliwatt of power. And class 3 device broadcast using up to 1 milliwatt of power. Mega dengan milli saya silap. Bukan mega, mega M besar. Milli M kecil. Macam megabyte tu M besar kan. Megawatt besar lah. Penakaran boleh mati je kan. Bluetooth link layer pula. Tadi physical layer, transport layer. Ni link layer dia. Layer yang kedua. Data link layer. Bukan transport. First layer adalah physical. Baseband and link layers Bluetooth device form into Piconet and Scatternet ataupun Scatternet and or Scatternet. And Scatternet or Scatternet. Kan? Sama ada N pun boleh, or pun boleh. Piconet consists of one master device that communicate directly with up to 7 active slave devices. Ulang balik tadi kan, multiple Piconet can also be combined into a single multi-hop SCARnet. Connection within a Piconet occurs directly over the one hop link between a master and a slave. Slave cannot communicate directly. The master may communicate with a slave during the odd number slot, and slave respond during the even number slot. Each packet may consume 1, 3 or 5 slot sebab dia odd kan. Dengan even tak boleh. Dia ada bagi macam tu. Okay, untuk middleware layer, ada middleware layer pula. Consists of several software. Many of components in this layer are optional. The component in the middle layer communicate with the transport layer using the standardized host controller interface ataupun HCI. Security, kita tengok security pakai 124 8-bit tadi kan. Bluetooth use a pairing process to establish connection and authentication between two devices. Mula pakai pin kan, lepas tu tak payah dah. The pairing process is performed using a series of keys as an input to the cipher plus block cipher. In the first stage of the pairing process, the device generates a shared 128-bit initialization key using the master's 48-bit hardware address, a shared 128-bit random number, and a user-specified pin of up to 128-bit. Mula-mula kita pakai pin. The devices then encrypt their link using this key and negotiate a 128-bit link key. The two devices then use the link key to perform a challenge response protocol. Ada encryption kat tu. Kena encrypt dengan decrypt. If successful, then the initialization key. That is how security on Bluetooth. Last ke dekat application pula. Masa dah habis belum? Ni last. Contoh kita dah bagi tadi kan, Bluetooth mouse, Bluetooth keyboard. Ni yang kita tak pernah dengar. Heart rate monitoring, automatic exchange of file, electronic business card, calendars, ada rupanya. The art networking ada, cordless connection from cell phone to hands-free headset, cableless connection to printer, fax, digital camera and video projector ni pernah tengok lah. Alright, tu yang ada dalam dekat Bluetooth. Yang paling banyak sekali adalah pakai AirPod, headphone kita kan, headset kita kan. Itu paling banyak pakai Bluetooth. Dan Bluetooth kita boleh guna untuk transfer file.